In section 2.1, we are going to talk about limits of a function. And to introduce limits, we're going to reference a quick video on the Khan Academy. Okay, well, that ends the video on the introduction to limits. Again, if you want to go back to Khan Academy and look that up, you can. But again, a very good explanation of what an introduction to limits is. Now, let's take a look at this example. Say we have the function f of x equals x plus 2, and we want the limit of f, or limit of f at x equals 3. So that means here's where x is equal to 3. Okay, and we want to know the limit as I approach 3 from the left and the limit as I approach 3 from the right. And we can see that as x approaches 3, the graph of the function gets closer and closer to 5. And if we were to start, say, at the point 1 and 3 and move to the left to get closer and closer to 3, you can see we're approaching a y value of 5. And if we were to start at the point 5, 7 and go closer and closer to 3 from this side, we would also be approaching 5. So again, we could say that the limit of f as x approaches 3 is 5. Another way of writing that is using a limit statement. So the limit as x approaches 3 of my function f of x is equal to 5. You might ask yourself, what's the difference between the limit of a function and the value of the function? Well, in this particular case, the value of the function and the limit were the same, okay? But this will not always be the case, as we saw in the video of the piecewise function on Khan Academy, on the last example when they had a piecewise function. The limit and the value of the function will not always be the same, and we'll explore that as we move on throughout the unit. Okay, let's learn how to read limits off of graphs. So this is the graph of h, and what's a reasonable limit for the limit as limit of h as x approaches 3? So it'd be the limit as x approaches 3 of h of x. And as you approach 3 from the left-hand side and from the right-hand side, you can see that the graph is approaching that open circle, and that limit would be 2. Even though the graph is not defined at 3, it still has a limit. So the limit would be equal to 2. All right, now let's take a look at the next example. So this time we have the limit as x approaches 6 of f of x. And again, if you want to take a look at that, again, you can see the limit coming from the left of 6 is approaching -3, and the limit coming from the right of 6 is also approaching -3. So this limit is -3. Now don't confuse this with the value of the function at 6. The value of the function at 6 would be the dot -5. So here's an example where the value of the function and the limit are not the same. All right, which expression represents the limit of x squared as x approaches 5? So basically what we're asking is, how would you write this statement in a limit statement? Okay, so we want to know what expression represents the limit of x squared as x approaches 5. So the way you would write this would be the limit as x approaches 5 of the function x squared. So your answer for this one would be C. Again, they're just trying to get you to practice writing your limit statements. All right, very important, and you might want to star this. For a limit to exist at a point, you have to check both sides. So going back to our original example, so the limit as x approaches 3 of the function x plus 2, we had checked from the right and we checked from the left, and they both were approaching the same value of 5. So this is very, very important. If we take a look at this example, and we were asking you to check the limit from the left and the right of 3. Okay, so first of all, let's do the limit as x approaches 3. And when we come from the left of a number, we're going to call that number 3 from the negative side. And this is my function h. So approaching 3 from the negative side or the left, we're going to be approaching a value of 4. If I approach 3 from the right-hand side, and we denote that by a positive in the exponent of 3. If I come from the right-hand side, you can see I'm approaching a y value of 6. So therefore, we could say that the limit as x approaches 3 of h of x, we would have to say that it does not exist, DNE. And why doesn't it exist? Because the limit from the left does not equal the limit from the right. So for a limit to exist at a point, the limit from both sides has to be approaching the same value. Now, the left side limit of 3 is 4, the right side limit of 3 is 4, but the limit at 3 doesn't exist. Okay, which of the limits exists? Choose all the answers that apply. So let's take a look. The limit as x approaches 3. Well, at 3, coming from the left and right of 3, they are approaching different values, so that does not work. The limit as x approaches 5. Well, coming from the left of 5 and the right of 5, they're both approaching this open circle. Yes, that exists. The limit as x approaches 6. Coming from the left of 6 and coming from the right of 6, they're approaching the same value. That exists. The limit as x approaches 7 from the left and from the right are approaching the same value. That exists. So only the first one doesn't exist in this case. All right, what would be a reasonable estimate for the limit as x approaches 1 of g of x? So I want you to pause the video quickly and give this one a try. Okay, hopefully you had a chance to try it. And a reasonable estimate for this as x approaches 1, approaching the left and right side, they're both approaching that open circle, which would be about negative 1 1/4 or approximately negative 5/4. Now you might have estimated as negative 1 1/3, but something close to that general solution. What would be a reasonable limit as x approaches 1? So again, the limit from the left and the limit from the right are both approaching 4. And again, don't be confused by the solid dot. That's the value of the function at 1. The limit would be the open circle. What's the reasonable limit as x approaches negative 4? Well, again, it appears to be approximately 3. I know it's a little bit above 3, but approximately 3. And we're approaching from the left and from the right. We're both approaching the same y value. And the limit as x approaches 3 in this case? Well, because the limit from the left of 3 is approaching 4 and from the right of 3 approaching negative 3, we would say this limit does not exist. Okay, let's practice a few more here. Okay, so the limit as x approaches 0. Well, at 0, the graph passes straight through that point. Coming from the left and the right, they're both approaching 1. The limit as x approaches 3, again, coming from the left and the right, they're passing through the point of 0. The limit as x approaches negative 1, again, is going to be positive 2. The limit as x approaches negative 2, well, they're both approaching the open circle, that would be 3. The limit as x approaches 2, again, from the left and from the right, they're both approaching negative 2. And the limit as x approaches negative 3 would be positive 2. All right, we talked about one-sided limits again. That's C with the limit as x approaches a number from the positive side. We call that a right-hand limit, and the negative is a left-hand limit. And again, for a limit to exist at a value, the limit from the left has to equal the limit from the right. And this definition is just a mathematical representation of that. So it says the limit coming from the right of b has to equal the limit from the left of b, has to equal L. And if that's the case, then the limit as x approaches b would also be L. All right, so from the left here, the limit as I approach 0 from the right-hand side is 3, from the left-hand side is 1. So again, this does not exist. All right, I want you to pause the video and give the next two, or give this slide a try, and we'll go look at the answers here quickly. Okay, I'm hoping you had a chance to try it. So the limit as x approaches 2 is going to be negative 3. The limit as x approaches 0 is 0. The limit at negative 2.5, well, negative 2.5 is right in the middle of that line segment. That line segment is at 2. The limit as x approaches 1 is 1. F of 1, that's the value of the function. That would be the dot at negative 2. F of negative 2 would be the solid dot at 2. The limit as x approaches negative 2 from the positive side would be negative 2. As you approach negative 2 from the negative side, it would be positive 2. So therefore, the limit at negative 2 does not exist. Finally, I want you to pause the video and give this one a try. Okay, in part A, f of negative 4. Well, at negative 4, there's an open circle at 2, so this does not exist. Limit as x approaches -4 from the left is going to be 2. -4 from the right is 2, and therefore the limit as x approaches -4 is 2. F of 1, well at 1 the y value is 4. As x approaches 1 from the negative side, limit is 4. As x approaches 1 from the right side, it is -2, so therefore this one at 1 does not exist. F of 6 is equal to 2. The limit as x approaches 6 on the left is 5. From the right, it's 5. And therefore, the limit as x approaches 6 is 5. Again, why? Because the limit from the left of 6 and the right of 6 are the same. All right, that concludes reading limits off of graphs. So there's a couple questions you can try from your textbooks. So give those a whirl and see how you do.